Hi everyone. Good afternoon. Thanks for joining me this afternoon. So today we're going to talk about Brownfields DevOps. And I'm going to talk about what I actually mean by that in a minute. But first up, a little bit about me. I work for Microsoft in the Cloud Developer Advocacy team. So this is kind of like evangelism, except we're advocates, which means we're not lawyers. We advocate for developers and we advocate for Microsoft. So it's very much a two-way relationship. Historically, Microsoft has had a lot of evangelists, and they will go out and they'll tell you how amazing Microsoft products are. And yes, we do that, but at the same time, we expect the community to tell us what we're doing right and what we're doing wrong. So that's my Twitter handle there, and I'm completely serious about this. If you are using any DevOps kind of tooling, VSTS, Azure, things like that, tweet me. If there's something wrong, tweet me. I will get the product team involved. I know myself and Donovan Brown, my boss, we've pushed changes out in the same day. So somebody has mentioned to us that there's a bug in something. We got the product team involved. They have created a fix and released a fix to it on the same day. So completely serious. Tweet us. We will get stuff done. If you don't use Twitter, so that demo visa works kind of everywhere. So demovisa.com. demovisa.me as websites, or even demovisa@microsoft.com will get to me. So feel free to send an email as well. I kind of use Twitter more than everything else, including like face-to-face conversations. Right? I use Twitter instead of face-to-face conversations. It's much nicer. Before I worked for Microsoft, though, I worked for a company called Octopus Deploy. Who knows Octopus? That's like nearly half the room, which is awesome. So I actually wrote the integration between VSTS and Octopus Deploy, so I have that kind of relationship already. But working at Octopus, I saw a lot of companies who were getting into DevOps, starting to do deployment automation and things like that. And prior to that, I was in consulting, so the same thing. I would go out to dev teams and I would help them improve their DevOps processes, even if they didn't call them DevOps processes, if it was just an extension of Agile. I saw a lot of different organizations and a lot of different companies struggling with certain things. I'm going to talk about that a little bit more later. So a couple of other things. I am Australian, as you may have noticed if you couldn't pick the accent. I'm living in Canada at the moment, which is a bit of a shock in terms of weather. I play beach volleyball, I surf, I dodge dangerous creatures when I'm back home, and I travel a lot as well, so just in case people care about me. I'm part of this team as well at Microsoft under Donovan Brown. I know some of you probably saw Donovan when he toured Europe a little while ago. So he is my boss. On the left is Abel Wang, and on the right is Steve Moraski. So Steve actually came from Chef. Abel's been at Microsoft for quite a while, working with VSTS. So I work with these guys, and we are all incredibly passionate about DevOps. So if you can't contact me, contact any of those people as well, and they can help you. And then our team is part of a larger team of cloud developer advocates, and we've got some amazing people, particularly in the open source community, who have joined Microsoft as a developer advocate. So people like Jessie Frizzell from the Linux community, you might know her, Brian Kettleson and Ashley McNamara from the Go community. If you do Node, you probably know John Papa. He's on our team as well. Scott Kate in the .NET community. There's a ton of people in that list. So that URL will give you a list to all the profiles and things like that. And yeah, you can learn a bit more about us if you care about other technologies that are non-Microsoft. All right, so let's get into it. And the number one question, which somebody asked me a second ago even, is what do I mean by brownfields? So I'm talking about Brownfields DevOps here. People are generally reasonably familiar with the idea of greenfields projects, which is where you get to do a file new project and you can start everything from scratch and work out exactly how you want to put the project together. By contrast, when I talk about brownfields, I'm talking about any project which, if you were to start it again, you know what you would do differently. So it doesn't have to be really, really old. It can be, I mean, I've written code like a week ago, and then you look at it again and you say, oh, I really wish I had used one of the 4 new JavaScript frameworks that have come out since I started. But it's, it's the idea of you already have this legacy architectural decisions and the process by which you deploy and so on. So how do you actually move on and try to move the needle in a DevOps perspective to try and get better at that process? So the first thing I'd say is if you're in this scenario, it's okay. Most developers are working on existing software. There are existing architectural decisions that impacts the way you work and make it potentially really difficult to do continuous integration and continuous delivery. But what you do from this point to move forward is the real question. It's very tempting to kind of give up and say, well, we can't do DevOps with our system because we have this dependency. Even things like PCI compliance and is it GDPR? GDPR, cool. Even things like that. There are ways that you can build that into your deployment cycle and your release cycle to make sure that you are ticking all the boxes for your organization. So it's tempting to say it's too hard, but there are things that you can do. And that's really what today is about walking through some practical things you can do with existing Brownfields applications to try and get better in terms of DevOps. All right, so let's talk really briefly about what DevOps actually is first. I assume because you're in the room that you are already sold on the idea of DevOps, but this is how Microsoft defines DevOps. This is Donovan Brown's definition that he made over a long period actually, and he's very particular about pretty much every word in this definition. So it's the union of people, process and products in order to enable continuous delivery of value to our end users. So there's a few really important parts of this. There's the people, process and products. DevOps is not something you can buy. So if somebody comes and says, look, here we've got this product, it will make you do DevOps properly, they are lying to you. They are trying to sell you something, right? You can't just insert a product into your process and all of a sudden you're doing DevOps. There needs to be a change to the way you work, and that comes both in the process of your development and your release cycle and how you monitor stuff in production and so on, but also a change in what people do. So people have to be bought into this idea. It's very difficult to kind of drag somebody along on your DevOps kind of journey. I hate the word journey. I was trying to avoid saying it, but it kind of fit. It's really difficult to drag people along on your DevOps journey. People have to be sold on this idea. They have to be invested in improving the process and making sure that things get out to production. The other really important part of this is delivering continuous value and delivering it to end users. Now, it's one thing to say, yes, I'm moving a ticket from the left-hand side of the column to the right-hand side, the right-hand column on my Scrum board, but that doesn't mean you're delivering value. I mean, if you write a new feature and nobody uses that feature, you have not delivered value, right? You have delivered a feature, you've done some code and somebody's going to give you a paycheck at the end of it. That's great, but the user is probably not going to, the user has not seen any value here. And it doesn't necessarily need to be just code as well. Like if your website needs to scale because of sudden load, that scaling effort may not involve any code at all. It may be somebody literally going and scaling up that website. That is value though. And the idea with DevOps is to deliver this continuously, not on a 3-month cycle or a 6-month cycle or anything like that, but do it as soon as the code is ready, as soon as the change is ready, and get it all the way out to your end users. Code that runs on your machine is 100% pointless, right? If it runs on your machine and it's not in production, it does not count. So getting it to your end users is really, really important. So that's great, but I haven't really told you anything about what to do yet. So we're gonna run through a few different steps about things that you can actually do with your applications to try and make things a bit better. All right, so step number 0, because everybody knows you start counting at 0. Step number 0 is establish a baseline, right? And this is all about working out where you are now and what your process is right at the moment. And this involves things like making sure you know how you work. So how an idea gets from somebody's head all the way into production and what happens after it gets in production. You need to know everything that's involved in that process. You need to know how you build your application, how you actually get the resources that you are going to put to production, how they get created. Is it a continuous integration server, like a build server, or is it Greg on his deployment machine, and if he's not there that day, you can't do a release, right? You need to make sure that you know what that looks like. Same thing with releases. Do you all come in on a Saturday every 3 months and hate each other at the end of that weekend because something went wrong and it's Brian's fault, and you know on Monday everybody starts looking at job sites to work out whether they can get a new job somewhere else. You need to work out exactly what you're doing. And the story might not be pretty, right? It may not be elegant. That's me when I started skiing in Canada, which was not long ago. So it's important to get all of this stuff down on paper, and there's two reasons for that. Number one is you need to know when you start automating this process and when you start improving this process exactly what you need to include in it. Like, do you need to have a check for how much disk space there is in production before you do that work? And it's very tempting to say, well, our deployment script is this Word document that we keep somewhere and we break it out every time we do a release. But everybody knows that document is not everything that you do. That document is what you think you do and what you should do, but then when you actually do the release, there are some other things that happen. Lots of blaming, usually, and things like, well, we forgot to write that step down. I'll update the document later on. So it's a good idea as well next time you do a release to maybe have a scribe, have somebody write down everything that happens, and that way when it comes to automating, you can revisit that list of things that you do, work out whether it's actually part of your deployment process or should be, and include it if it is. The last one as well, how do you measure? Do you wash your hands of it when it's in production? Are you like, it's in production, that's fine, let's move on to the next thing and not worry about it? Because it's important that measuring what happens in production and using that information to feed back into the work that you do is included in your DevOps lifecycle as well. So step one is really to do that. I mentioned one reason, which was to make sure that when you start automating, everything's okay. The other reason is a little bit more touchy-feely. Like it's a good feeling to be able to look back at what you've done a couple of months later and say, this is how we used to operate, and now we've done things a lot better. We don't have to do all of this stuff anymore. You know, releases are much smoother. So that's the other reason you might want to do this. So assuming we've established a baseline, the next thing to do is to get your software into a good state. Who here, and no judgment in any of this, but who here releases in the order of every 3 to 6 months or longer? Releases a new version of their software. Okay, there's a few people. Every month or so? A few more hands? Yep. Now, there's nothing necessarily wrong with releasing every month. It's more important if you improve your cycle time. It's more important how quickly you can release rather than how often you release. But if somebody told you, the people who are doing these 3-month releases, if somebody came to you and said, now we want you to deploy your software 50 times a day, in a lot of cases, that is just not feasible. Like, you can't just release it 50 times a day. There's a lot involved in that deployment process. You need to run through a whole lot of testing. You need to, there's a whole lot of steps that are required to build the application, to release the application. It's not feasible. So the step number one is really to get your software into a state where that becomes feasible. So there's a few tips here. Number one is try to get to one code base. And I mean this in a couple of respects. I mentioned I did consulting before. The first client I had when I was doing consulting brought us in because they were having trouble updating all of their customers. They had about 30 franchisees who were running a version of their software, and they were having trouble getting updates out consistently. So I came in and I asked them what version of their software each of their customers was on. And one of them laughed at me and said, we don't really have versions. We just have different code for all of our customers. And when there's a new customer, we copy somebody's code and we put it in a new repository. Which means every time they fix a build or fix a bug, they have to fix it in 30 different repositories. And sometimes they don't. It's very difficult to maintain this. So they had all of these different code bases. Now that's probably not familiar to many people in the room, but what might be familiar is multiple branches from the same product. I'm a really big fan of trunk-based development, which means that almost all of your code gets back into your master branch really, really quickly. If it's a tiny little change, I am happy for somebody to check that directly into my master branch. If it's a slightly larger change, create a feature branch or some kind of branch like that that's very short-lived, anything more than a few days and you're going to start to have problems, and merge that back into your master branch, probably with a pull request or something like that. Now that's also what I'm talking about with one code base. Every time you release your software, it should come from one branch. You shouldn't be doing a release from this particular branch over there, which kind of matches master, but we've cherry-picked a few things over, and we've cherry-picked some back the other way, and then we have to do this big merge to do a deployment. The other thing which causes problems here is if people have different branches for their different environments. Because when you do your merge to your production environment, that merge creates a code base, and that's the first time that code base has ever been compiled, is just before you go to production. And the phrase, that's the first time it happened, just before it goes to production, is not a good phrase, right? You don't want to ever do something for the first time in production, right? You want to do it in a test environment. And everybody has a test environment, by the way. It's just that some people also have a different production environment, right? If you don't, your production environment is your test environment, and that's not a good scenario, right? So one code base, try to get everything in this trunk as much as possible. That way, whenever you do releases, you're releasing from that same code base, the same one that you've used to test all the way through. I'll expand on that in a sec, but there's obviously going to be variations between the different branches, between your different customers, between your different environments as well. So it's important to be able to isolate those, so when you make changes, it's less likely to impact other stuff in your code base. So as an example, here's a very similar bit of code to what was in this customer that I was talking about. I've simplified it slightly, but not a great deal. And what they would do is when they were deploying this to a customer who was based in Australia, for example, they would comment out the bottom line and uncomment the top one and compile it and deploy that to their customer. Now, they had a list of all of the different places they needed to go and make changes, which makes it foolproof, obviously. But it's very difficult to kind of maintain this. A slightly better way of doing it might be something like this, where it's all in the one code, it's all in the one file. You don't have to do a recompile to get this stuff to happen, ideally. All the code's there, but it's still isolated. You can still say, well, we have this code path. I need to change the tax rate in Australia. I will just modify that code. That's not entirely ideal. It's very likely that somebody's going to have this.country equals UK and then comment that out and make it Australia as well. So you can go a bit further with things like dependency injection, inversion of control, and have actually isolated bits of code. So this is an implementation of an interface for the UK, right? So you would have a different file, a different bit of code for each of your countries, and then you can resolve that, which one it runs, at runtime. Now again, you could still have that line of code that says this.country equals UK, or the sales tax calculator equals the UK sales tax calculator, and comment that out and put the Australian one, for example, which is a bad idea. You want that configuration to be outside of your code, right? So you need to externalize the configuration that chooses these different code paths. Now, when I say externalizing a configuration, I mean things like config files, or even databases, environment variables, even third-party APIs that you can call to say, what is my setting in this scenario? But the point is, it's not inside your compiled code. So the advantage of that is that you can set that configuration when you deploy. You build your application, and then when you deploy it to your test environment, you set that configuration at that time, but you're still deploying the same binaries. At runtime, you read that configuration, and then you decide which code path, or in the case of dependency injection, which implementation to use at runtime. So things like a config file which sets that environment. So when you deploy, you're still deploying exactly the same application, you're just changing the config. We've probably seen this, a lot of you have probably seen this in config files for database connection strings, for example. You might have a connection string that talks to your test server, and then when you deploy to production, you update that to be your production server. So that's pretty familiar to a lot of people, I think. The advantage of doing all of this as well is that you end up building your application once and deploying it many times through your environments. So you're not building a new branch of your code to deploy to production. You have already tested exactly the same code in your test environment and your QA environment and your staging environment, if that's what you're going through. It's just the configuration that's changed. Things like, what database do I talk to? Stuff that you're not really going to know until you get to that environment anyway. If I'm talking to a different database, there's not really much you can do to make sure you're talking to your to your production database before you get to production. So you're testing exactly the same binaries. So build once, deploy many really means that you're testing the same bits everywhere, right? You know if you find a bug in your test environment, that bug is going to be the same bug that's going to be in production, so you can stop that. The other thing that this gives you as well is the ability to test the same deployment process. So not just the bits themselves, but how you deploy those bits. Because you're doing exactly the same, because you're deploying exactly the same software, you can deploy it exactly the same way, ideally. And you can go even further and use things like containers. So you're literally deploying the same application because it's just an image in a container, and you're just updating it to be in production or staging or test. One thing that I will say that you need to do if you're doing this properly is to get your versioning right. So because everything is in this one branch, it's easier to do versioning. There's kind of two rules. People will tell you that you should really use semantic versioning or semver, which is basically major.minor.patch. And there's very strict rules around what you're allowed to break when you update the patch version or the minor version or the major version. And that's good if you can do it, but we're talking about Brownfields DevOps, right? So you may not have that option. These are the two rules that I would say you always need to follow if you're doing versioning properly. Number one, every build has a unique version. Every single time you compile your application, there is a new version number. So you should never be building your application and building version 1.1, then updating your code and building version 1.1. Now you have two sets of binaries that do different things, and it's very difficult to work out which one does which. The other one is that every time you build the code, it has a higher version, so you know which is more recent. And this makes sense if you have that one branch, because you have changed the code to move that branch forward, so you should change the version number to move that forward as well. So either of these versioning schemes, I don't really mind what you use. The first one is semver, but the second one is just a date-based one. But you can glance at that and say, well, this is newer than this one. It's very easy to tell which one has new code in it. But those two rules, that's really all I would care about. That you can look at two artifacts, two outputs from your build and say, this one is newer, we should use this one. It allows you to tie that version number to specific bits of work that you've done as well. One more thing in terms of getting your code into a good state is to start measuring stuff in production. Right? It's very easy to actually add this to applications these days, and there's really no excuse anymore for finding out about a problem from your customers. Like if an exception is occurring in production, you should know about it before anybody screams at you, right? Things like, if you're using .NET, things like application insights are trivial to add to your application, particularly if you're running in Azure. In Azure, half the time you don't even need to modify your code at all. You just say, start instrumenting that app, and it will start feeding you information about exceptions and things like that. If you're using the whole kind of Microsoft platform with VSTS and so on, you can see each release as it happens and then be able to link not just the exceptions that have started occurring, but you can link them to the code that changed at the time that release happened or for that release. So measure in production, just start adding this stuff to the application, and that will allow you to feed back into the work that you're doing. The earlier you can find out about a problem, the better, because it's already in your head. If you just did that change and now you're getting exceptions from it, you don't have to remember what you did at that time. So start measuring in production. A little bit of a recap here about getting to a good state. Get to one code base, isolate your variations, but then externalize the configuration. So you're building your application once, deploying it many times. And then have a look at versioning, make sure you've got a good versioning strategy, and then measure what's happening in production. So once your code is in a good state, it's important to be able to actually deploy it without it being a big issue. I always say that production should just be another environment. If you can deploy to test, you can deploy to production, and it shouldn't be any scarier. I mean, it's maybe a little bit scarier because if something goes wrong, somebody's in trouble, but it should be the same process all the way through. One way of doing that as well is to try to get to this idea of stateless deployments. So what do I mean by a stateless deployment? Let's think about the traditional way that you might deploy updates to your application. So you have application version 1, you update some stuff, and then you apply those updates to version 1. So version 2 sits on top, and then version 3 sits on top of that. The problem with this is you have a dependency on what's come before. You have a dependency on that server, that environment, and the previous version of the application. Now that doesn't have to be your code, it could be the third-party API that you're using, or the .NET framework that's on that machine. A better scenario is if you can deploy version 1, and then to deploy version 2, that's the whole thing. All the dependencies, everything that you need to get to version 2, and version 3 again is everything that you need. Now, in a practical sense, it could literally be the same as what's on the left there. You may say, do I have version 1 and all the dependencies? If so, forget about it, I've already got it, go to version 2. But if not, deploy everything. Now, there's two reasons you want to do this. Number one is that it's fantastic if your production server dies, and I have been in that scenario quite a while ago. Actually, the first job I had out of university, a server completely died, and then it took 2 months for somebody to get it back into a state where it was ready to go again. Part of the reason is that that server was an iMac, you know, the colorful bubble things that was sitting in a server room with a zip disk for backups that nobody ever checked. So when they went to restore it, there was nothing on it. That and the hard drive that had died wasn't manufactured anymore, so they had to go out and get somebody to build this hard drive for them. Anyway, that's a whole different, that was a learning experience. So if your production server dies, it's much less of an issue because you can just deploy onto a new server. Your deployment includes everything that you need. The other reason is this is fantastic for testing. If you have a feature that you're kind of working on, but you don't have an environment where you can just ad hoc test stuff, spin up a new machine, deploy to it, play with it for a bit, yeah, that's great, and then tear the machine down. It's really good for testing if you can do that deployment in a holistic kind of stateless way. Now that's fine for applications, for binaries and files and things like that, but what about databases? Especially relational databases where if you change the schema, the whole thing is different, and you can't really move back with schema changes. One of the techniques that's used actually by the VSTS team is that they make sure their database releases go out first. So they do the database release, make sure it still works with the old version of the application, and then they will release the application on top. There's usually two ways that people do database deployments. There's migration-based deployments where they have a bunch of scripts that know how to take it from the current state to the next state. And this doesn't break what I was talking about before because they say if it's a brand new database, then run from script 0. If I've already run the first 10 scripts and I've got 2 more, then just run 11 and 12. So that migration kind of moves you forward. The other one is model-based, which I'm a little bit scared of. The tooling is great these days, but model-based upgrades are essentially you're saying this is what my database should look like. Go and have a look at what production looks like and then just run some stuff to bring it up to speed. And I'm saying that in a particularly negative way because that's how I feel about it. I don't like the idea that a script is running against my production database that I've never seen before. So I like being a bit more explicit with migration scripts. But when you move forward with these scripts, it's difficult to say, oh, there's something wrong with that, we need to roll back to the previous version. So the strategy that I was talking about that the VSTS team uses is called like transitional deployments, where you basically have a point where you can update the database, but if you need to roll back your code, then it's still okay. The old code can still talk to the new database. So visually, this basically just means that each version of your database that goes out is also compatible with the previous application. So if you weren't doing this, and you updated to version 4, for example, and version 4 wasn't very good, and you needed to roll back your application, you can roll back the application generally fairly easily. You can just write the old files over the new ones. But the database is now in a state where, how do we get that back to the way it was? Do we just hack against production and try and get that working again? Or do we roll back, like restore from backup and lose a whole lot of data? There's not really a good option there. But if you've done this ahead of time and you know that this works with the previous version of the application, that's great. So as another practical example, let's say you have a database table with customers in it, and somebody decided that date of birth should be a string a while ago. Great idea. So rather than just changing it to a date column, which doesn't give you a way back, you might run both columns for a while. You could maybe even put in a trigger temporarily to say, when I write to one column, write to the other. And that's not an ongoing solution. That's not something you should leave in place for a long time. So you do want to clean this up later, but at least it gives you a period of time where you can roll back your previous version of the application if you really need to. Yeah, we've got somebody groaning about using triggers, which is legit. You shouldn't use triggers in general. Yep, there you go. So the idea though is that you have this period of time where you can roll back if you need to. And that's often a manual kind of, how do we treat it this time? And make sure that make sure that you can actually roll back if you need to. Now, there's more work in this. Each time you do it, there's a bit more work, but it really, really reduces your risk when you actually do your deployments. So deploying without drama is really about these three things. Getting to a point where you can do a stateless deployment. So it doesn't matter what the server looks like, you can just deploy it onto that server. If you're halfway through a deployment and it fails, that's fine, just start again. Having migration scripts is my preferred way of doing database upgrades, and then have some kind of transitional period with your database upgrades where if you do need to roll back, it's fine. It's much less risky actually making that update. These are all techniques that you can use to actually deploy your application with less drama. Once you've done that, it's really all about increasing your cycle time. So when I talk about cycle time, I'm not talking about, again, how often you actually deploy to production. If you deploy to production 50 times a day, that's fantastic, but you don't necessarily want to deploy 50 times a day, right? Maybe your customers don't want things to be moved around constantly. Every time they hit a new page, something's different, right? So it's much more important how quickly you can get a change out to production. If you fix a bug, how long does it take for that bug fix to get into production? And if it's months, then that's not an ideal scenario. It should be as soon as you can feasibly get it out there. In other words, delivering value continuously to your end users. So number one tip in this, and this is the way that people do DevOps, and the thing that a lot of people think, well, DevOps is just automation. And it's not, but automation is an incredibly important part of it. Automation, you can think of it like replacing humans at stuff that humans are bad at, right? Humans suck at things that they repeat over and over again. If you have to do the same thing over and over again, you're not going to do it the same way every single time. Like we are not very good at that. You shouldn't get a human to do a computer's job, all right? That's recorded, by the way, so when Skynet takes over, I'm on the side of the machines. Humans make a lot of mistakes, right? So you don't want, if you can do something with a script, the script is going to do the same thing the same way every single time. When you're doing your automation though, one tip that I would give you is just automate one thing at a time. Don't try to pick up your entire deployment process, automate it in one go, and then drop it and say, now we've got an end-to-end DevOps solution, all right? Pick the hardest thing at the moment, automate that. Then pick the next hardest thing and automate that. I've seen companies who will say, right, we're doing DevOps now, no more code for 3 months. We're going to pick up our entire process, automate the whole thing, and then we'll start writing code again. And that does not work. That leads to managers saying, well, this was a stupid idea. Let's go back to the way we were doing it, right? So just pick one thing at a time, tune it, make sure it's all right. The end goal, of course, should be to automate all of the things, right? As much as possible, get humans out of that process. Now, automation is great, but you don't want everything to go to production. You want to be able to catch mistakes as early as you possibly can. So if I introduce a bug, that should not get to production. That automation should stop it from getting to production, and that's all about building a pipeline. So yes, a pipeline is great in that it'll automate everything from start to finish. If a developer writes some good code, goes in one end, magic happens, money comes out the other end, right? The automation just makes all of that happen if everything's okay. But there's plenty of opportunities in this pipeline for actually testing whether your code works and preventing bad stuff from getting to production. Have you heard the term shift left in terms of DevOps? You can see exactly what shift left means in this diagram. It basically means if there's a problem, I want to discover that problem as far left as possible, right? If I've introduced a bug when I'm writing my code, the ideal is if I find that bug when I run my tests locally, because then I can fix it immediately. If I can't find it then, maybe I'll find it in the build. If I can't find it in the build, in the test. But shift that problem discovery as far left as possible. And there's all of these opportunities in the pipeline to prevent bad stuff from getting to production. So building a robust pipeline is really, really important. Having all of this stuff, so by the time you get to production, it's run through all of your filters and you know that it's very likely that you haven't introduced anything bad. One thing I will say about your pipeline as well is if a bug or something bad gets into production, that's not necessarily just a problem with your code. It is also a problem with your pipeline. So the idea of red-green refactor for bugs, where instead of just fixing a bug, you write a test that goes red to prove the existence of the bug, then you fix the bug and make sure your test goes green, and then any refactoring you need to do, you have this test that runs over this area to make sure that bug doesn't come back. You can do the same thing with your pipeline. If bad stuff makes it into production or a deployment fails, change the pipeline to catch that problem, then fix that issue and make sure your pipeline stops that problem from getting through to production next time. That way you will never make that mistake again. So that's really handy. If you want to move really, really fast though, I would strongly suggest looking at feature flags, or feature toggles is one of the other names for it. A feature flag you can think of more or less as a glorified if statement. So you have your existing code in your application, you write new code rather than changing the existing code. You write new stuff and wrap it in a flag. So when the flag turns on, it will start using your new code. And then if it doesn't work, you can turn the flag off again and it should run through the old code path. Now this obviously requires some architectural changes. In general, big changes are not edit the existing code, they're abstract the existing code, abstract away the existing code, and then write a new implementation and wrap that in a feature flag. But it's a really, really handy way of deploying to production with much less risk. You can turn the flag on, and then if it doesn't work, turn it off. Great way of testing features as well. So deploy turned off, it allows you to test in production, which sounds bad, but testing in production the right way is fantastic. If you have a customer who really wants this new feature, but you're not 100% sure whether that feature is ready yet, you think it is, so you can turn the flag on for just that customer, get them to try it out. If they say, oh, I know you've done exactly what I asked for, but it's not actually what I want, then you can turn the flag off and go back to the drawing board. It introduces a lot less risk. It means you can move stuff to production much less riskily, riskily, is that a word? It's a word in Australia. Bigly. The other thing you can do, the other reason you might want to do this, and this is really handy for selling this idea to the business, is you separate the release of your application or a release of a feature from the deployment. Your deployment is purely a technical event. You can deploy features to production on a daily basis, but if they're wrapped in feature flags that are turned off, your customers don't see them, which means your marketing department can decide, for example, when you release this feature to the customer. And not only are they releasing the feature when they want, they're releasing a feature that you have probably tested in production, so you know it's going to work at that point. So that's really handy as well. So improving the cycle time is about these three things. Automate, build a really robust pipeline so you can trust you can just write code, and if it's good, it will get to production. And then have a look at feature flags for reducing that risk even further, getting to production. Now, one thing I haven't talked about is the shift in culture. I've mentioned process and products a little bit. Haven't mentioned any specific products, but you can see how they fit into that life cycle. I haven't really mentioned people very much, though. And people are just as important, right? I've heard a lot of people, DevOps speakers, say that DevOps is not a process, it's not a tool, it's a culture. DevOps is a culture, which I think is probably true, but it's also not very valuable if people are trying to do DevOps. Has anybody been in an organization? I have, where somebody came in and said, by the way, we're doing Agile now, we have an Agile culture. I went, cool, do we change anything? They're like, no, you're just like an Agile architect now. A scrumafall, waterfall-y, scrumafall, yep. So, we're just doing this now and that's the culture now. That does not work. Changing a culture by telling people the culture has changed is not effective, right? The culture will start to change as you start doing this stuff, but there are some really important things to watch out for. And number one is no silos. Does anybody have a DevOps department? And again, no judgment. Does anybody have a DevOps department in their company? Yep, there's a guy with his hand up in the back. Oh, and in the front. So, we used to have, this is where I'm looking at the time, and I could go on a rant for 45 minutes, but I've only got 5. So you get the 2-minute version. So you know how we used to have DevOps was supposed to solve the problem where we have this dev department, and they write their code, and they say, yes, this is built, this is ready to go, and they throw it over the wall to their ops people. And the ops people will try to push it out to production, realize there's a few steps that the dev people forgot to tell them. The dev people are like, well, obviously you need the .NET framework. Like, I'm not going to put that in the document. And they end up hating each other, right? They don't talk ahead of time. DevOps is supposed to solve that problem, get people speaking together. You do not solve a problem with 2 silos not speaking together by putting a new silo in between them, right? Now you have 3 silos that don't speak to each other anymore. The devs can't release their code, give it to the DevOps people who do some DevOps stuff, who give it to ops people, and the ops people have to maintain that. It doesn't work, right? Building a new wall is not a great solution to any problems, right? I can only say that in some countries. So try to avoid silos, right? Of course, if you're not in a position where you can change the org chart, then that's really, really difficult. You might just be told, no, we have a DevOps department, and this person is responsible for the DevOps department. They obviously are not going to try and get rid of that department. But there are things you can do. So one thing I would advise is using the term task force, or whatever the equivalent is in your organization. A task force is basically, hey, this last deployment went really badly. Let's get together a few people from the dev team and from the ops team and get them in a room together and establish a task force which can work out why the problem failed, why the problem existed, what went wrong, and how we can avoid it next time. The good thing about a task force is it doesn't adjust your org chart. The person whose job is basically just to keep their team isolated from everyone else, they can keep that job. That's fine. They can own their silo. But a task force allows you to actually speak to people. This works even better if you can make it sound like it was your manager's idea. If you have that conversation and they say, we should do a task force, you're like, that's an amazing idea. That gets it implemented a lot better. So a task force is a kind of a way of getting around these silos if you need to. The last thing really around culture is the idea of making sure you fix it for next time. If something goes bad, or something goes wrong in a deployment or a build or any part of that cycle, it's really important to kind of foster this idea of fixing it so it doesn't happen again. And you hear the idea of like blameless cultures and things like that moving forward. I think Microsoft's one is a learning, I should know this. It's like a learning environment where nobody gets blamed for problems. You just look at the problem and say, right, this is why it happened, it's not going to happen again, right? Because we've fixed it for next time. And if you start to develop this culture of, yes, something went bad, but let's just fix it so it doesn't go bad again, you'll start to see more opportunities for introducing some great things into your pipeline. Like, hey, we had to do this step manually last time. It wasn't broken, but it was a bit slow. Let's just spend an hour and automate that. So you start seeing these opportunities, it starts to develop that culture for you. So those 3 things on culture. No silos. If you can't do that because you have no control over the org chart, then look at task forces or some other kind of managerial buzzword that can get around that problem. And then try to foster this culture of fixing it for next time. Don't be content with just doing a once-off fix. Fix it so it doesn't happen again. So I just want to call back quickly to that definition of DevOps, which is union of people, process, and products in order to enable continuous delivery of value to our end users. That's really what you should be looking at. The idea of combining all of those things in order to get real value out to the end users on a continuous basis. Get it out as soon as it's ready. That way the customers are going to love you and you're going to actually get things done and feel like you're delivering value, which is important for wanting to stay in your job beyond if you don't count anything else. So we looked at really briefly why we bother with DevOps at all. I assumed everyone was kind of sold on that idea, so I did that really quickly. So why bother? Then the steps to actually make change. Establish your baseline, work out where you are now, which allows you to revisit it later on and say, look how far we've come. But as well as that, make sure you have covered everything when you start automating. Get your software into a good state. There are some things you can do with your architecture to make it easier to deploy your application. And then once it's easier to deploy, actually get that process in place where you can deploy without it being a big deal. Try to get to the point where production is just another environment. It happens the same way. We can do it whenever we want. And then it's all about improving that cycle time. So get to the point where deploying to production is literally just clicking a button and 5 minutes later there's a new version up and running. Now that can be a long path, but it's something that's definitely worthwhile doing. And across all of that, you have this culture shift, ideally. So making sure that you try and avoid silos, actually work together because it is about people as well as process and products, and then fostering that idea of fixing it for next time so it doesn't go wrong more than once is really important too. And hopefully that will help with some things that you're working on at the moment. Thank you.